Okay, so we're going to be learning about area and perimeter today. The area is the space that occupies the inside of a flat object. So all of the yellow would be considered the area of the object. The perimeter is the length of the outline surrounding the shape. So it's basically the black line, the outside of the object. Have you learned about this before?
Oh, yeah.
Yeah? Okay, yeah. Some of this should be review. So you can find area and perimeters of a bunch of different shapes. The only difference is the formulas change how you find it because the shapes change. So then the outer and the area and perimeter have different relationships. Okay, so for the area of a square, since squares are even, you do side length times side length to get this. And then, does that make sense? You've learned like most of this, right? Yeah. Okay, and then for the perimeter, you just want to add up all the side lengths because then you're just completing the box. And so then it would be 4 times the side length because there's 4 S's. And if you multiply them all together, it'll be the perimeter. Okay, so do you want to try it? You can grab like a piece of paper and you can use a calculator if you want. So first, let's calculate the area.
So the area would be 13 times 13, so that would be 109.
Mm-hmm. And then
the perimeter would be, let's see, 52.
Correct. Good job. Okay, so for rectangles, since the side lengths are different, we do length and width as the 2 side lengths. So the width and the length multiplied would be the area of it, and then the length, width, all added up would be the perimeter. And we have to use different variables for these two because the side lengths aren't the same as squares. So, do you want to try this one?
Okay. So the area for this one would be 24 plus 16 for the area. So that would be 40.
If we go back here, the area would be length times width.
Oh.
You need all of the boxes to be included. So.
But then 24 times 16.
Which, yeah, you might want to use a calculator to solve that. But it's 384. But yes, you were correct. And then for the perimeter, what would it be?
The perimeter would be 40.
Well, that would be the perimeter of 2 sides, but we need the other 2 sides as well.
Oh, 80.
Yes, perfect. Okay, so now I'm going to introduce more complex shapes. So for a triangle, you do the height times the base divided by 2. And you do that because a triangle can make a square if you put 2 triangles together. And then you use the same exact formula that you did for a square, and you do base times height, which is basically length times width, which we just did with rectangles. And then we would have to divide it by 2 because we're only using half of that square. Does that make sense?
Yeah.
Okay. So do you want to calculate the perimeter? Oh, and then the perimeter would just be adding up all the sides.
Yes.
So do you want to try calculating them?
Okay, the area, let's see. So that, right, okay, so length times width, 16 times 14. Let's see. $124, and then we divide this, so 62?
Yeah, perfect. And then what would be the perimeter?
The perimeter would be, let's see, 30.
Yeah, perfect. Okay, so for a trapezoid, you would have to do, there's 2 bases on a trapezoid, the shorter base and the larger base. So you do both bases, add them together, and then you would multiply it by the height, and then you would divide it by 2. And similar to the triangle we just did, if you put 2 trapezoids together, it'll make a parallelogram, and then you're basically just taking the area of a parallelogram and dividing it by 2 to get the trapezoid area. Because you see the A here, and then the A here, and the B here, and the B here. So if we add those up and then divide it by, and multiply it by this, and then divide it by 2, we should get that. And then for the perimeter, which is not on the slide, but it's the same as every other perimeter, you just add up the side lengths.
Okay, so the area. And then
perfect. And what would be the perimeter?
The perimeter would be, let's see, 48.
Yeah, perfect. Because you do 15 plus 13, and then you want to make sure you add 13 twice. So it'd be 15 plus 13 plus 13, because you need to add in this side plus the 20 on the bottom. Okay, final challenge. Circle formulas. So a circle is a little bit different because it doesn't have edges and straight. Circles are a little bit different because they don't have any corners and they don't have any straight lines because it's all round. So the way you figure out the area of a circle is you use the diameter, which is the length that touches the 2 ends going through the center point. And then half of the diameter would be the radius, which is just from the center point to one of the edges. Does that make sense?
Wait, wouldn't it, if it's halfway, why is it going like sideways, the radius?
Oh, because a circle is even on every, so the radius here would be the same as the radius here, and the radius here, and the radius here. Because radius is the diameter, so it's just from the center to the side. And it's like have you ever seen one of those like spinny wheels that you can play on a game?
Yeah.
And you spin it? It's like that. So I could just spin this and it'll be the same everywhere, and it'll always touch the edge. Okay, so pi. Pi is a very important value in circles, and it's the distance around a circle divided by the distance across the circle. So let's try it.
Wait, did you read the last slide again?
Yeah.
Oh, it is a distance.
Okay, so using pi, the area of the circle would be the radius squared. Do you know what squaring is? So it's radius times pi. And pi is a value. It's 3.1415, and it goes on infinitely, forever.
Okay.
So then we would take the radius, which is half of the diameter, and we would do radius times the radius, and then we would multiply that by pi, which is a constant value that like you don't really need to understand the value, and you don't know how to find it. No one does, because it was found a long time ago, but everyone uses it. Okay, so do you want to try finding the area?
Sure. So basically it's like the area around the whole circle times like the diameter.
Okay, so here, the area would be the radius times pi. So it'd be 5 times 5, which is 25. So you can just put it as 25 pi, because you don't have to multiply out the pi, because then you'll get a bunch of decimal points. So you can just say 25 pi, and you don't have to multiply the pi. And then for the circumference, it's 2 pi r. So 2 times pi times the radius. So all you have to do is do 2 times the radius, and then you can just add pi at the end, because you don't actually have to multiply it out, because then you'll get a bunch of decimals and it'll be less accurate. Okay, Okay, so do you want to try calculating the circumference?
Sure. Okay, so it's 10 pi.
Yeah, perfect. Okay, so how do we apply this into the real world? Home designers use it to measure bedrooms, kitchens, bathrooms, or pool sizes in homes. For example, if you're like putting carpeting in your home, you have to make sure that the carpeting fits exactly into the area of the room, like the area of the floor, or else you would have to get a new carpet. And then architects use it to help plan building sizes and placements. Farmers can use it to help plan how much space each plant needs to be in their field. You can use it to plan what big objects, items can fit in your room or home. So basically, it's used just for planning things and like the organization of things to make sure that everything fits before you attempt to do anything. Okay, so the first activity we're going to do is you're going to be designing a bedroom. Okay, so you're going to need one piece of graph paper, one pack of colored pencils, one piece of cardboard or cardstock. It's optional, you don't need that. A ruler, tape, or glue, and a pair of scissors. So I'm going to give you a little bit to go get all those materials, okay? Perfect. Okay, perfect. Okay, step 1. Make sure the graph paper is horizontal and fold both sides towards the center by about 10 squares. So you want to make sure that it matches this image. So about 10 squares in, you want to fold it. So there's a little space in the center as well. So instead of the paper being this way, you want it to be this way so that when you fold it, it's wider.
Like this?
Oh, no, the other way. You want it to, that's vertical. We want it to be horizontal.
Or like this?
Yeah, and so then unfold it and then fold the sides in from that other
Oh,
way.
okay, okay.
So it's like, yeah.
So like this?
Yeah, perfect. Yeah.
Okay.
Okay, so now we're gonna open up the flaps and fold them down from the top. And so you actually already did that step because you already have, do you still have those folds in your paper? Because you're doing the same thing, so you're just gonna fold it down from the top and bottom instead of from the sides.
So wait, how do I do it?
So
like do I open this
that.
up?
Yeah, open that up and then keep it horizontal and make sure, yeah, the folds are on, yeah, put it down like that, flat.
Okay. And
then fold from the top.
Like this? And then go like that?
No, if your paper's like this, you're just gonna fold like that and like that.
Okay, so like this? Like I have to fold it like this?
Yeah. Fold
it. From the top.
Because you're basically doing what you did. You folded from the side, and now we're unfolding that and folding it from the top.
Okay.
Yeah, perfect. Okay, so now you're gonna make a cut at where the black lines indicate. So completely unfold yours, and you're gonna see that you have like little squares. Yeah, so for the top two of those little squares, do you see where the black line is on my screen? You're gonna wanna cut that. Just cut it straight. Don't cut the square out, just cut the black line. We want to keep the square in. Just cut the black line and do it on both sides. Well, no, do it on, you only want 2 cuts, not 4, okay? You only want the 2 on the sides.
Like this?
Yeah, perfect.
Okay.
Okay. And now, do you see the bedroom we created? So we have a wall, a wall, a wall, a floor, and then these are not drawn on because if we fold those in and tape it, it'll become, the walls will stand up. Does that make sense? Do you understand that? Okay, so now try to use at least one of each shape, square, rectangle, triangle, trapezoid, and circle, we learned to start designing your bedroom. So here's an example of a bedroom. And obviously it does not need to be this much detail, but you see the circle here, a square, another square, a lot of squares, a lot of circles mainly. Try to use some trapezoids and triangles as well in your design, like this is a triangle. And design your home. So, yeah. So design, do you want me to keep the example up while you're coloring?
Yeah.
Okay, yeah, I can keep this up.
So can you keep like all the shapes list I need?
Oh, yeah, here, I'll type it into chat. Those are the 5 shapes you're gonna need. And then obviously you can use them all more than once.
Okay, I'm done. You're muted.
Oh yeah, can I see your design?
Sure.
Ooh, it's super pretty.
Yes.
Now we're gonna finish it up by gluing or taping those two flaps up so then the walls actually stand up. So we're gonna add on to the activity we just did, and now we're gonna calculate the area of everything that you put into your bedroom. So all you need is a scratch paper and a pen or a pencil. So you're gonna first list out everything you put into your bedroom. And so just make a list of every shape and like name it so that you know all the different like circles and triangles you put it in there and you can distinguish between them.
Let me go get a pencil.
Okay, yeah. So you want to list everything that's in your bedroom. Okay, and since we're running out of time, we only have to list 5 of the items.
And
So we can finish the activity. And then now you're gonna have to calculate the area and perimeter of each of the items on your list. So you only have to do it for 5 of them.
Okay.
And if you need help with any of the formulas, I can go back to the slides.
Do we do it in inches or centimeters?
Whichever you want.
Okay.
Probably centimeters would be easier because everything's pretty small. How many of the objects have you completed?
4.
4? Okay, perfect.
Okay, I'm done.
Okay, perfect. And we're gonna skip the next step because we didn't calculate all of your objects. And then there's no one else to show your work to. But which of the items in your room took up the least amount of area out of the items you calculated? Like which shape type?
My cabinets.
The cabinets?
Yes.
How could you improve your design to create more space or fill up more space?
Well, I could make them if I since we didn't have enough time. But if we had more time, I could make them like bigger.
Yeah.